Hi. As C++ developers, we are faced with a very complex and very fascinating challenge, in my opinion. And that challenge is the very success of our language. I intended to let that sink in for a few seconds, but actually Björn said exactly those words yesterday, so you already thought about it. The existing C++ code line is massive. We are talking billions of lines of code that were written over decades. And this massive existing code line is very, very valuable. We don't want to rewrite anything from scratch. On the other hand, C++ is evolving very quickly in very interesting ways. And so we have this challenge. How do we make sure that our code that is probably tied to this huge existing code line, how do we make sure that this code line can evolve? So I'm Fred. I work at Murex. Our company makes software for capital markets and has been doing so for the last 37 years, I think. So yeah, let me tell you, the code I work with is very strongly tied to a huge code line that is sometimes very old. And so that's a question I ask myself a lot. How do I make sure that my code can evolve without breaking anything? How do I make sure that I can refactor, that I can clean my code? And if you want to talk about code cleaning, I'll start with talking about the history of cleaning itself. So, I'm sorry for this image. Clearly, this is very misogynistic. That's not my point today. We are at the end of the Second World War, and after the Second World War, and Hoover and a few companies are trying to sell this new object, a vacuum cleaner. Vacuum cleaners are fantastic. You used to need a day to clean your carpets. Now you can do it in less than an hour. So clearly, with the vacuum cleaners, housewives are going to spend a lot less time cleaning, which is what Hoover is selling. Except now that we live in 2019, we know that that's not what happened. Actually, what happened was two things. First thing is we completely redefined, as a society, what a clean house is. Before vacuum cleaners, when you went in somebody's house and a carpet was not perfectly clean, that was normal. It takes 1 day to clean all the carpet in the house. You do it every 2 weeks. That's normal. Once vacuum cleaners became the norm, if you went to somebody's house and the carpet was not perfectly clean, it was a dirty house. First effect of having vacuum cleaners. Second effect is that a decade later, we had wall-to-wall carpentry. And this couldn't exist if we didn't have a vacuum cleaner to clean it. So instead of making people who clean life easier, we actually redefine what we expect from them, and we allow the apparition of something new that couldn't exist without a vacuum cleaner. That's a phenomenon that happens a lot in our industry. Some tools that was supposed to make our life slightly easier actually completely changes how we think about something or how we work. One example I like is Git. Before Git, you had many version control tools, and you could branch. You would take your full repository, copy it completely, and somehow link the histories. Git arrived, and Git branch is instantaneous. At the time, I think nobody realized that it would change anything. They were used to branch once a month at most. Usually, they would run it during the night. Nobody cared about having instantaneous branching. Except nowadays, we use Git and we branch multiple times a day. The fact that we went from taking a few minutes to being instantaneous completely redefined and allowed us to create new workflows, new way to work. And my opinion is that ClientID is one of those huge, drastic change under the guise of some convenient tool. Think about it. Before ClientID, we had mainly two big ways to refactor. First one is the boilerplate rule. You leave the code in a better state than you found it. You find a function whose name you don't like, you correct it. You find a row loop, you replace it with an STD algorithm, of course. And in general, you try to simplify the code. The boilerplate rule, I love it. It's not going anywhere. It's very powerful on hotspots of your code, which is what you want to refactor. You don't need to have any kind of budget or anything. It's part of your business as usual. And it's very easy to merge. You were already fixing something in this position of the code. If the refactoring changes, breaks something, you were already going to have a conflict anyway. So it's very nice, but with the boilerplate rule, you're not going to change widely used APIs. You are trying to fix a bug in a function. You're not going to rename the function if it's called by I don't know how many modules that you don't own. It's also not the right place for risky refactorings. You are trying to fix an issue. That's not the moment where you want to add another one because you try to do something risky. Also, it's not the right place for what I call coordinated refactorings. Like the company says, oh, now we are changing our naming convention. Please change it everywhere. Boilerplate rule will not help you with that because you are only refactoring your hotspots and some files are never touched. So at the other side of the spectrum, you have what I call the golden boy refactoring. You go see your boss and the boss says, okay, you have unlimited budget. You stop everything you're doing and you refactor. Wow, don't you love it when it happens? I'm pretty sure many people don't know how that feels. If you can have some golden boy refactoring, you are going to tackle very complex tasks. And it can lead to huge improvements for your API users. So that's great. But already it's kind of a myth. Very few people have the chance to have it. But if you have it, it's very repetitive. The first one is very exciting. Oh, I'm refactoring some file. And then you have hundreds of files where you have to do exactly the same thing. It's very error prone because you are changing hundreds of files manually and you are going to miss something. And it's a whack-a-mole. You are trying to remove problems and the rest of the company is working on their business as usual. And they add problems as you try to smash them. If you are slower than them, you will never finish your refactoring. So both of those kind of refactoring clearly work and will stay, but there is a place for some other way to refactor, namely using something like ClientID. Now, during the whole presentation, I'm going to say ClientID and explain how ClientID works, but I'm pretty sure other tools will appear in a near future that will do kind of the same thing and will have exactly the same challenges and the same possibilities. So for those of you who don't know at all ClientID, it's a C++ linter. It's built on top of Clang. It allows through static analysis to find bugs and bad patterns in your code. And also it can automatically fix them. It's built on top of Clang. So Clang is this compiler for Objective-C, C++, and C. And this is a very complex explanation of how compilers work. So they take a source file, they generate what we call an AST, an abstract syntax tree. Then they do a lot of magic, and it compiles for your target platform. So clearly, what I'm interested in is the AST here. What is an AST? So I have one file with one function called getTheAnswer. For Clang, this is a translation unit with a function declaration whose child is a count statement everything between brackets. And this compound statement has two children, a declaration statement and a return statement. And that's how many compilers work, generating AST. But Clang is unique for one thing. That you see next to each node, I have the line number and the column number of what part of my original source file generated this node. That's where everything will be built on top of. This is the same chart as before, except now we see that the arrows goes the other way too. ClientID is going to search for specific AST nodes, and then we'll be able to go back to the original file and act on the original position in the file that generated this node. That's what ClientID allows me to do. So, for example, you can use ClientID to find all the 4 nodes that are using the old iterator syntax and instead replace them with 4 range loops. That's very convenient. I see absolutely no drawback to run that on your whole code line. You could also search for all the nodes that are auto pointers and replace them with unique pointers, and do that smartly enough that you replace all copies with stdmove, and everything continues compiling well. All of that is very nice, but what is really changing my life is that ClientID also has an API where I can write my own checks. And that's what's going to change a lot of things. This API is very simple, actually. You just have to override 2 functions to create your own check. The first is register matchers. You are just registering the matchers for AST nodes that are going to be searched by ClientID. And every time ClientID will find one of those nodes, you will be called on check, where you can react to finding something. Creating your own matcher is not that hard, because there is a web page on LLVM's web page that just lists all the existing matchers. And then you take this page and you just line up dominoes. I know that I'm searching for a core expression. Well, core expression takes as an input a matcher of core expression. You search all the matchers of core expression you have, and you find that trolley is the one you want. And the trolley takes a matcher of declaration. You find the function declaration that is what you want, etc., etc. And so just through this page, you usually find exactly what you want. And it explains quite well what each of those is doing. That's for the theory. What can you do in practice? I don't know if you know, but in C++, you can either use double ampersand or use and that's exactly the same for the compiler. I was talking with this guy online who had moved from using double ampersand to using and with his whole team, and they really liked this move to using and. And is convenient, but especially not is way more convenient than just a bunch. And so they were very happy. The team was very happy with this move, except they had moved mid-project. So they had a mix of and double ampersand in the same project, which they didn't like. And you cannot just go with the regex and replace all double ampersand with and, because you have R value references and you have forwarding references. And actually, you can replace all of those with and. That's probably the opposite of what you're trying to do. So he was kind of stuck with that. I said, oh, I'm pretty sure it's a very easy ClientID rule to write. So let's write it. We start with our register matchers. We are going to register one matcher because we are searching for binary operators whose name is double ampersand. That's it. That's our matcher. And I have this bind. In matchers, I can give an ID to any element of the matcher. So here, we are going to give the ID myop to the binary operator itself. every time ClientID will find a node that is a binary operator whose name is double ampersand, I'm going to be called on check. And in my check method, I'm first going to get the node I ID'd as my op. I'm going to attach a diagnostic to that. So every time we find a node, we display this diagnostic saying double ampersand could be replaced with and. I also attach what we call a fixit, which is how could we solve this issue. And now when this team runs a rule, they have this kind of thing. One warning generated, double ampersand can be replaced by and then you see the line of code where the node was found and the replacement that could be applied with a squiggle on the end. So with just this very few lines of code, we could solve an issue that they couldn't solve with a regex or manually. Another anecdote, this one is mine. I work on the UI APIs at Murex, the server-side UI APIs. And so, as I said, our code is 37 years old. My version control tool only goes 15 years in the past. But in the last 15 years, the third parameter of display screen has been dead. It does nothing. And the thing is, why would you keep a useless parameter? Well, because last time I checked, this function was called in 40,000 files. Usually multiple times in each of the files. So I'm not going to go through 40,000 files and manually suppress dead parameters. Especially because, no, on top of that, I'm not going to do a regex either, because there are macros in that, there are people who put comments inside the function calls, etc. A regex would be impossible too. With ClientID, we can create this matcher that finds call expression, whose callee was a function declaration, all of this you saw earlier, whose name is display screen and parameter count is 4. I attach an ID to this node, which is function to clean. And now, I will be called every time such one of those nodes is found, and I can get the node, get the second argument, attach a diagnostic to this second argument saying, oh, this parameter is dead, and create a fixit which is just to remove the dead parameter. So with that, when one run of the function, I could clean 40,000 files that had dead parameters in them. So I think already with those two examples, you can see that how we can solve problems that weren't solvable at all before. I'm adding another example. This time I'm not going to show you the rules because they are way bigger and we don't want to put that on the screen. But imagine you have this pure abstract interface that you own, but every other people in the company are using your API and they are overriding the read method. And the method takes a message, so they write their own way to read a message, and they have to return an int, which is 0 if it worked and 1 if it failed. And perhaps we can add a few other magic numbers in it, I don't know. And in 2019, you don't want such interface. You don't want to return a magic number when you could be returning an actual enum class that would actually explain what's happening and not just say 0, 1. With ClientID, we could, so this is, somebody is overriding my method with that. They are initializing the variables and doing early returns and doing some tests on the body of the code and then returning a result. With ClientID, I can write a rule that will find all the return statements. From those return statements, I could search for all the variables that are returned by a return statement. And for each of those variables, I could look at where are they assigned a new value. And if they are assigned a new value, I will recurse and find, okay, what am I being assigned? Is it a function? I can recurse on this function. What is it returning, etc. And in the end, with just one press of a button in your whole code line, you can replace everything with a nice enum class. You could write a rule like that. Actually, I did for one of my functions that is not read, but had the same kind of way to work. There is another huge advantage to Clang on top of being able to do stuff like that. It's merge. If you have millions of lines of code, you probably work with quite a lot of people, and the code is moving around you. If it takes you 1 week to have your rule written, and you try to merge your changes, you will probably have conflicts with other teams who did some work during the same time. If you had been working 6 months, removing the dead parameters by hand in each function, the amount of conflicts would be even huger, and you would have to fix everything to be able to merge correctly. With the ClientID rule, you just say, okay, you go, and you apply your rule on top of the new code. It takes you 5 minutes, and you've solved every conflict you could have. That's invaluable. Right? That's great. So all in all, ClientID has allowed us to solve problems that used to be unsolvable, to refactor at large scale, and to completely revolutionize the code, which leads us to this nice slide. ClientID is fantastic. Thank you. Goodbye. Have a nice day. No, wait. Oh. Okay. I'm French, so it really kills me to say that, but are you sure you want a revolution? Because I don't know if you know, but last time we had a revolution, people got beheaded. Imagine you go to work, you've been working on this nice feature that is actually needed by the company. You've been working for a week, you arrive in the morning, you synchronize your code, and nothing compiles. You search, oh yeah, Fred removed the dead parameter. Okay, I'm going to fix it. I was very angry with this dead parameter anyway, so that's nice. Sometime later, you arrive, you synchronize your code again, and it still doesn't compile. Oh, what happened? Oh yeah, Fred changed the way read returns. Now it's not an int, it's an enum. And now you have to rewrite all your read methods by hand because you had changed that locally, but not in the repo. If that happens every morning, guess who's going to be beheaded? I don't want that. There is another issue. I told you I changed 40,000 files. That's so cool, right? Who does validate a 40,000 file change? How do you make a code review of that? How do you get the green light from all the teams whose files you just changed? So the secret is I didn't ask anybody, I set it to production, and I was very lucky it did work. But don't do it at home. And clearly, it was to remove a dead parameter, so that's kind of easy. You don't want to do that for something more complex. So how do we make sure that we can review our code? There is another big issue, is that C++ is hard. Don't know if you heard that before. It's hard. Last year, Timur did a presentation about variable initialization, and he was using this GIF. That's about it. Now, you are trying to write your AST matcher, and you want to catch variable initialization. Did you really think about all those use cases that you were going to catch with your variable initialization? If you're anything like me, you will fail many times. Well, proof is every single rule I showed you earlier has mistakes in them. I'm really sorry about that. I didn't put them on purpose. I failed when I wrote them, and then I kept a copy to try to trick you too. So replacing double ampersand with and, that seems very easy. Except, as I said, double ampersand and and are exactly the same thing for the compiler. So actually, our diagnostic is going to say, oh, here, you have and written, you could replace it with and. Thank you. What? A very small problem. It's very easy to fix. Just in your check, you check if it's already and or not. There is a bigger problem. In C++, you can override the double ampersand operator. And if you do so, you lose short-circuiting. So for Clang, for the compiler, those are two completely different AST nodes that don't act the same way. So if you want to catch those two, you will have to write a second matcher that looks a lot like the first one, but is called, I think, CH's binary operator or something like that. That's not huge problems. We can fix both of those with one line for each of those. But you have to fix them. So this dead parameter thing, it's great. Actually, the matcher works very well. Problem is, many people were doing things like that, where they were using a macro and passing me false or null in display screen. So when I ask ClientID, hey, where is the third parameter? ClientID says, hey, here. And so I say, please, ClientID, remove the third parameter. Here you are. That's not what I wanted. Once again, that's pretty easy to fix. ClientID gives you the tool to say, OK, I want to use macro definition position or macro usage position. You just have to add a new line to say, OK, you just use the position where the macro is called and not inside it. I told you I did this great rule that replaced old ints with enum classes, and that was fantastic. Actually, it never worked for lambdas. When you have a lambda in your function, and you try to find all the return statements inside the function, the return statement of the lambda is also inside the function. So you are getting all the returns inside lambdas too, which is not what you want. And also, templated classes don't work at all like other classes. So I had both of those that were not taken into account the first time I wrote this rule. That's not a huge issue. For these cases, I had like 3 usages of each. I fixed everything manually. We are C++ developers. We make many mistakes. We have very hard things every day. So that's not really a problem. What's a problem is if you cannot see that you made a mistake. With a 40,000 file change list, you have 2 solutions. Either you are very lucky or your compilers catch the mistake, or you are very unlucky and your customers find the mistake. But you will never catch it yourself. So, more generally, like Jurassic Park used to say, just because you can do it doesn't mean you should do it. So, I've been talking for the last 30 minutes about ClientID, and I kind of broke everybody's hope by saying that, oh, okay, it's not going to work, and what can we do? The solution is to have an incremental approach instead. Who was at Titus Winter's talk earlier? Oh, I'm surprising absolutely nobody. So that's what he calls a multistep refactoring. So a simple solution with a dead parameter problem was just to say, okay, instead of removing the dead parameter in the 40,000 file at once, I just create two functions. I mean, I keep the old one. It's now calling the new one, which doesn't have a dead parameter. And if I have that, I can replace chunk by chunk in the code and replace the old call with the new call. I don't have to replace in the whole code line. I don't have to break everybody's code, everybody's local code. We can stay in this position for a few weeks until everybody has removed their dead parameter in their code. Incremental approach or multi-step approach can be hard, as Titus proved by talking about it for 1 hour. In our case with the reader and this read method, that's way more complicated than with the dead parameter thing. One approach I propose is to add this new method, readenum. I still have the old one. I add the new one. It does nothing. It's empty. So it compiles for everybody. I didn't break anything. Then I go in other people's code, and they are overriding the old method, as they should do. I'm going to write to overwrite readenum and put the new code in readenum, which is returning an enum class. I'll keep read, but just as a wrapper that use the enum class and does the insync. If I do that, I can do it file by file. Everything still compiles and works as it used to. Once I have done that for every single override of my function, I can go back to my API and remove read with an int. And now I only have readenum, which becomes pure abstract. And I know that every code that overrides reader is also overriding readenum, so it works out of the box for them. Thing is, we wanted to change the return name of read, not readenum, which is kind of dirty. So we have to do a second step where we write a new read method that this time returns the enum class too. And we have to do exactly what we did earlier, but in the other side. We move the content of readenum into read until everybody is overriding read, and then we remove readenum. That's a lot more work than just breaking everybody's code and going full. But it's definitely worth the work, the additional work. It's a lot more work for you because you have to think about this path where you go from one position to the other without breaking any code in the process. It's also a lot more work for another reason. It's that you will have many new problems that are going to arise because of that. For example, what is a write pull request size? I don't know. Is it one pull request with 40,000 files? Probably not. Is it 40,000 pull requests with one file in each? Probably not either. We don't want to dose our app. Thing is, I don't know what the actual answer is, the right answer is, because it will depend on your company, on the refactoring you're doing, on many things. Why do I say it depends on your company? It depends on how many people are supposed to review code, how much time they have to review code. It also depends. If I'm removing a dead parameter, it takes a few seconds to check that it's okay in a file. You can probably send hundreds of files at the same person, and they will review very quickly. If you are changing from int to enum, it's more complicated. You have to check that everything is working correctly. So you probably want smaller pull requests for this kind of problem. So yeah, clearly there is something between politics and programming that you will have to solve for each of your use cases. Another problem is that you will have to automatize everything. If you work at Murex, if you work at Murex, you're good. If you work at Google, you're probably good too. But otherwise, if you are the first one to do this kind of thing, you will have to automatize. You don't want to create a few hundred patches by hand by running ClientID in different folder. You don't want to send the pull request by hand one by one. You don't want to wait for confirmations from each team and merge each of the pull requests by hand. So you will have to automatize everything. This is something you have to pay only once, but you will have to pay it. It's also more work because we are back to the Wormhole problem we had earlier with Golden Boy refactoring. I am trying to move from a display screen with 4 parameters to display screen with 3. But I still allow display with 4 parameters to exist. So what if people continue calling this one? Because they like it, they are used to it, so we don't want that. One solution is to add deprecated to the old one. Otherwise, there is a very nice tool that you could use for that. It's called ClientID. Yeah, a recursive presentation. No, you could run ClientID, for example, on your pull request. You run it just before a pull, on the code just before the pull request, just after. You diff, and you have the number of new rule broken that arise because of the pull request, and you can react as you want. Perhaps you want to block the pull request completely and people have to fix it before sending it to production. Perhaps you want to let people decide, or I don't know, but that's a good approach. The added advantage is that you are protecting your current refactoring, but you're also protecting your company perhaps against a few patterns that you know exist in your company, and you can have this ClientID that makes sure it no longer happens anywhere in the code. And finally, finish. This one is super important because with display something for display screen, for example, we have now 2 functions instead of 1. That's not a gain. That's more complex than it used to be. That's completely okay because we are in the middle of a refactoring. Dirtying the code in order to make it better afterward, it's perfectly okay. Now, if you don't finish renaming your function and you keep both, and you move to another change, and you also keep both versions of the new refactoring, etc., at some point your code is going to be a mess, and you will be more bad than good for your company by doing half refactorings. So clearly finish all of those. In conclusion, just like vacuum cleaners actually didn't make anybody's life really simpler, I'm not sure ClientID is really making our lives easier. It's going to completely redefine what's expected from us. Like, yes, you can do this huge refactoring. Now you have to do it. Display screen, you cannot say, yeah, there are 4 parameters, but it's because it's so much work to remove one. No, you are expected to do it. In the future, we'll have to find, each of us, sustainable approaches to refactoring. We cannot just throw huge refactorings at our colleagues like that. And it's highlighting what I call higher level problems. Problems that used to be there, except we weren't efficient enough to see them. Like, yeah, code review is nice, but perhaps it's not the right tool when you have thousands of files that were changed, and the change is pretty simple to describe otherwise. And finally, I think ClientID, just like vacuum cleaners allow the operations, something that couldn't exist without it, I'm sure that some things are going to appear in the future that I don't foresee yet, but that will completely change how we work. And I'm very excited to see it. So thank you.
Let's go to slide 57.
I'm glad I still have batteries on my remote control. 57 or 47? Yes?
What happened to ReadBody? Did it get recursively refactored?
So the question is, what happened to ReadBody? Yes, you have to recursively change also ReadBody.
It also matches?
Yes. ReadBody has to return now a name class, and so you will have to run the same thing in ReadBody, where you are going to search for all the return statements and find where the variables were created and stuff like that. So that can be huge. In my case, it did work. I can promise you that it will work in every code line. I'm sure there are some cases where it can be very complicated if you have function pointers and stuff like that. But that's the kind of thing you can try to do. And yeah, it's fantastic if you can write a ClientID rules that solves everything at once. Once in a while, you have to just run the rule, see that it doesn't work completely because you've broken a few places, fix them by hand, and reapply the rule and see if it's fixed. I wished we didn't have to, but sometimes we have to. And especially with very old code where you have void pointers that are passed around and change, and you have no idea what the type is and stuff like that. You might have to fix that by hand before.
So
yes.
For someone that's never written a Clang-Tidy pass, what is the fastest way to get up and running?
So there are a few ways to be started and running. There are very interesting talks and very interesting blog notes, blog posts. I think Visual Studio blog has a very interesting set of articles about that very subject.
I would suggest look up Stephen Kelly.
Yeah, Stephen Kelly.
Yeah, Stephen Kelly has a series of blog posts. Some of them on his blog post, some of them on Visual Studio.
Yeah, so that's what I was referring to. So Stephen Kelly, yeah, he did also interesting talks, which you can find on YouTube. And at CppCon conference last year, a few months ago, sorry, Jeremy Dummel did a very interesting talk that sadly isn't up today on YouTube, but I promise it will be before the end of the week. And he is doing from scratch, writing a rule that is pretty complicated by using all the tools that are necessary in the process. Because clearly LLVMs has very, very nice tools. Not LLVM, ClientID has very, very nice tools. You have client queries that allows you to search and try to find out what's happening. You have, they have a script that generates a rule for you, and you just have to change the matcher, but there is already a matcher, there is already the template, you already have a name, etc. So yeah, there are resources on the net to do that. And you can also just check out so Client Extra Tools repository and look at a few rules. Some of them are very complicated, but some of them are pretty easy, and you can read them on what's happening.
Hi.
Hi.
I was just curious to know where in your software team you were running this. You know, is it you only as maybe a software lead, or is it running on a CI system or on each team member's?
So the first experiences I did were on my machine, and then I create a huge Git change, and I send it to production through hopefully the right channels so that everybody can check it. Now what I do usually is I create the rule, and then I split it with scripts and send mails to the teams that are concerned. We are also in the process of creating CIs that would automatize part of this so that people that are not me can also run a few rules. Like this display screen where I remove a dead parameter. I wrote everything, I hard-coded everything to show you, but clearly it's something that you want to parameterize and then give a tool to everybody saying, okay, we run that with the name of the function and the number of parameter, and it will remove the dead parameter for you where you want.
Hi, thanks for the talk. Could you go back to the implementation of the check function for a second?
Yes. Which one? So this one?
Yeah. So
yes.
I see that it displays a warning, that as you
yes.
Explained, but where does it actually do the change automatically?
Okay. Oh, by the way, something. Sorry, I will go back to your question afterward. Just here we are catching the third parameter, which is one with index 2 here. You could write a rule that catches automatically the right parameter in the matcher, and then you would have to do almost nothing here. Just it's not convenient to read on a slide, which is why I took this approach, but sometimes you have different ways to do. So to answer your question, how can I automatically fix? It's very easy. Here you see I run ClientID with the name of my checks on a file. If I pass ---- fix, it's going to fix it instead of displaying a warning. That's all.
Hi. I had a question related to some of the content you had about sort of a strategy of the automated changes for actually, the automated process of turning these into separate pull requests, getting things merged. Something our team had done before for probably more trivial refactors was binary diffing, where we'd actually look and see before and after, did we change the binary output of something?
Yeah.
Is that something where you had considered it as integrating into part of the process of creating these pull requests, or trying to find if there is a way that can be incorporated into understanding what is safe?
So yeah, the question is, could we use, for example, binary comparison to see if we didn't break anything? I think that would be very nice in some cases. But I'm pretty sure most of them are going to change slightly the binary, even if in the end the behavior is the same. Just like, yeah, with name of function and stuff like that, we are probably changing the ABI slightly, even if we don't change the behavior. But I'm sure it's a tool that could be useful in some cases. Absolutely. Thank you.
Hi. I'm curious, what's your workflow for handling automatic fixes that actually touch header files? And if you, especially if you want to get good throughput and try to parallelize the fixes, because in a large code base, you wouldn't want to run your tidy automatic checks serially. You want to parallelize if possible.
Yeah.
But when some fix might touch header files, they might get stumped over each other. So what's your strategy there?
So yes, that's a very interesting question. That clearly comes from somebody who's been dealing with that.
I confess, yeah.
So the thing is, yeah, you have two CPP files that include the same header file. And if the problem is in the header file, both are going to try to change the same header file. The solution we use is actually to generate, instead of passing ---- fix and changing on place the file, you can generate an XML file and with a diff. And then you have a client reply patch, I think, or client reply fixes, I don't know, patch.
The Python script? Or?
No, it's an actual client tool that runs, takes a folder with XML files of diffs and applies them. And so it will detect that it's the same change and it will handle it correctly. Actually, if you try to generate twice exactly the same XML, it will Sorry? Okay, client reply replacement. So yeah.
Excellent.
So, thank you again for your talk. I was wondering, so how is that like working when you have, is it like you're branching Clang-Tidy from LLVM and then adding all of your changes, refactorings, and how does that work, for example, with parameterization?
Yes, so you can parameterize your rules with ClientID. And so yes, for the simplest rules that we see here, that's exactly what I did. I create my own rule by just branching and creating my changes. You can also try to, for more complex refactorings, we work outside of we just use the libs, the libutil, and we write our own tool that is going to change everything.
Okay, thank you.
You're welcome.
Hi, thank you very much for your interesting talk. I was wondering if you encountered any refactorings that you wanted to do, but which you just couldn't get done with this approach. Like if there's a limitation to what you can do.
Yes, actually, using ClientID, it's... Well, now I'm not a huge expert of ClientID. I've been using it for the last year, and we did some big refactoring. But sometimes it's hard to you see something and you say, oh, that's probably a very easy ClientID rule, and it's definitely not. On the other hand, sometimes it seems like it's going to be complex, and it's not. A colleague of mine who's been doing that for more time than me was blocked, for example, with a very simple thing, which is you have variable declaration at some point in the function, and usage are way later, because that was the C style. And he tried to write a rule, and I think he never managed to have something very clean that does it, for example. That's something that seems not that hard, but that could be.
Okay, thank you.
You're welcome.
Especially in more complex rules like the one you described, changing the return value from 0, 1 to a result. How do you have guidance on how to avoid clashing fixed hints, like issuing a fix or like a change to the same location multiple times?
That was Victor's question, and so the answer is, no problem. So the answer is you can generate XML files with changes instead of immediately changing the code. And so it generates all the fixes, all the diffs in XML files. And if you try to add the same diff a second time, it will not be added to the XML file. That's something that's embedded in ClientID. And then you have client apply replacements that apply the whole folder of changes at once. But clearly, yeah, that's a big problem that arises when you try to do rules.
Hi, thank you for your talk. Is there any way to place new rules without modifying the Clang binary or source code? You mean like having your own project that you can have a project that depends on a client like,
without changing the code?
If I want to create a new rule, like
yes.
You actually compiled it into Clang-Tidy, right?
Is
there
yes,
any way to just
it's a separate library, so you don't recompile the whole Clang-Tidy code every time you change your rule. It's just recompiling the lib in question. So it's already quite...
okay, thank you.
It means you get a new binary for time, right?
Can you just do it in some kind of source file, like the data file with a rule file or something like that?
You can... I'm not sure about this one. I will try not to say something stupid by saying I'm not sure. But you can create tools of your own on the side, which will be just standalone executables applying one rule in particular. So that's perhaps a solution for you.
Okay. I have some comments to the question that they just asked. Regarding the branch your ClientID and then add your own checker compiler into the binary, what we did is that we modified ClientID a bit that enable you to specify I want to load a certain share library from a certain location, which will take some conversion files. I think that this may be a good one for the ClientID to leave this kind of way to let user can extend that.
Okay.
That's my personal view.
So make ClientID extensible easily with...
We changed that a bit.
Yeah. Yeah,
probably.
That's very interesting. Have you tried to contact them and... yeah, have you tried? Perhaps at least send an email. And
we did that kind of maybe 1 year ago, and as a past.
Yeah, but you've seen at least 2 people ask the question right now, so it seems interesting. You should try to contact them.
We do have this kind of problem because we also do some code migration tools, and that tool is keep changing, and I do not want to rebuild ClientID every time when I change my code. Right. Another thing that they mentioned about regarding this changing the header files and then there's a conflict. We did something tricky that we mimic the compiler and instead we emit the replacement information into the .o file. It is not really a .o file, and then at the end it will combine all the .o file and do some deduplication. So thinking that as a kind of a compiler that compile the .c file into .o, right?
Yeah.
So we generate this replacement information into the .o file, and when you really link several .o file into a binary or share library, at that time we will do some deduplication.
Okay.
Yeah.
That's
It's
that's
tricky.
very cool.
One question I have is that did you try to change like one class to another, and which will have different constructor? Because we found that it's really challenging since the constructor can appear in very different forms. It's very hard to iterate.
That's kind of the same issue as initialization before.
Right.
Yes.
Right.
I don't think I have. That's interesting. No, I haven't. That's that's a good point of working with some very old part of the code, is that it's usually an alloc and a free, so you can find all of them and they will look the same.
Or would you have found that no matter what you did, that's always a case that you
Yes.
didn't cover?
Somebody who did the modern way and broke everything, yes.
Thanks.
Thank you. Thank you.